Thank you very much. Okie doke. So let me go back here, sample student page, blah, 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 blah. Yeah, you should be able to click on this first one here. We all see the same problem. And that's the problem on your paper. So I encourage you to take notes and enter the stuff into the system, just so you kind of get a feel for both of those things. But in general, kind of the idea here is that we're going to manipulate the standard form. I'm sure you remember the standard form of a circle, having seen it so much in geometry. That's actually the simplest diagram. It's under the one that says circle, which makes sense. So if you remember, the general equation for a circle is x minus h squared plus y minus k squared equals r squared. And remember, the center of the circle is actually h comma k. We can pull that directly out of this general formula here, h and k. And the radius is, of course, r. So radius r. And there's the radius. So just by making the equation look like this, we can identify some specific features from it. And so what I want you to do is kind of get into the habit of rewriting what you see in the exact format as this kind of general form here. And so, you may be able to skip this step and just see it. But notice how this is subtraction. I'm going to rewrite this as subtraction. This will be y minus 12 squared equals, and 100 can be rewritten as a perfect square, 10 squared. So see how I've rewritten the addition as subtraction here? So that would be minus a negative 2. And what that allows me to do is see that the center is negative 2, positive 12, and that my radius is 10. Just like this is r squared, that's 10 squared, so my radius is 10. And x minus h gives me the x coordinate. And so that would be negative 2 here, even though it's positive down here. We want to rewrite it in the subtraction. And that's going to let me pull those things out. So your center here should be, negative 2, 12, with a radius of 10. So we should be able to knock that one out pretty easily. I'm sorry if I seem like I'm in a mood today. I'm not.
Because are you subtracted because in the formula?
I just don't feel well. So.
You said subtraction.
All right. So that's the circle, the first one. Let's go on to the next one. This one says to graph the conic, and I've actually clipped the answer this time. You won't be able to see it on your screen. But the first thing it wants you to do is, it's like, hey, what conic section is this? And you can tell by the formula that it's a circle. And because I'm telling you it's a circle. Okay. So when we graph one of these, you want to put it into the general form, which is the x minus h plus y minus k equals r squared. So I've rewritten it. X plus 1 becomes x minus negative 1. Plain old y. I'm going to put in the invisible numbers there because that's really going to tell me what that center is going to be. And then I'm going to have a radius. Anytime you are working with the graph of a circle, you need a center and a radius. And so the center of this one, and these are just my notes, the center is at negative 1, 0, and it has a radius of 9 units. And so when you go to construct that circle, you'll put the center at negative 1, 0. And then you'll pull the radius out 9 units, which would not be to 9. Of course, you're at negative 1, so that would be just to 8. And then you'll be able to graph that circle, and you should be good to go. Okay. So make sure you can input that and you know how to graph it. You should end up with something that looks just like this. What is it? Hit start over. There's a red button that says start over. Refresh the entire tab. There we go. So we'll just select this. I don't know what's up with yours. We'll go back and fix it. Yeah, don't know. Don't know why it's doing that. We'll go back and fix it for you. It's not a big deal. All right, questions so far about circles. This should be a review from last year. All right, so now it's turning it around on you and it's giving you the graph of a circle. And it's asking you to write the equation. And so remember, this is x minus h plus y minus k squared equals r squared, where the center is hk. So let's go pull the coordinate of the center. What is it? I think it's, what is it? 5, 4. Well, the radius, unfortunately, is not directly on any particular coordinate. So we're going to have to use some stuff for that. So we're actually looking for the length of this radius. How can we find the length of this diagonal line? We're going to do Pythagorean theorem, construct a right triangle with a hypotenuse of that radius, just kind of like we were doing the other day when we were working with the other conics. This is a strategy that works all the time. So you can also use the distance formula if that's your preference. So the center, and then you have this point on the circle. What's that point on the circle right here? 1, 2. All right, so this would be 4, right? And this would be 2. So I can find the hypotenuse using the Pythagorean theorem. That would just be 4 squared plus 2 squared. I'll take the square root of all that. And that should give me C. You could just eyeball it, but you're not going to get it if they're in between like that. So that'd be 4 squared plus 2 squared squared. That'd be 2 root 5, which is approximately 4.47. Or 4 point, I don't know how it wants it. This would be about 4.47. Or let's just keep it in the exact term here. Let's do 2 root 5. So the radius of the circle is actually 2 square roots of 5. So let's go plug everything in up here. Let's go plug everything into this equation. So this would be x minus 5 squared plus y minus 4 squared, because this is h and this is k. Just plugging those things in. And then we're going to have this radius squared. I don't know what that is yet. I think it's like, what, 20? 2 square roots of 5. Let's just be sure. That'll be 20. So that's what you should enter. In the place where you are writing that equation. We're tracking how to plug this into the formula. Questions? So the steps here were, I was given this graph, and I immediately knew that in order to write the equation, I needed the center, I needed this, this, and this. I needed the center and the radius. Well, the center was very easy to find because it was just a point on the circle. And then I had to actually calculate that radius because it wasn't right on a grid point. I couldn't count. I wasn't able to count the length of this radius. So I had to use the Pythagorean theorem to get it. I took the radius and plugged it into the formula for r. So I squared it. And then I just put the center in for h and k. Okay? All right, moving on. All right, this one's a little bit different. And so the circles should have been, although a far away review, a review nonetheless. And the parabola is similar. But if you look at your formula sheet, you'll see that this is the information for the parabola. And notice that you have two different equations for a parabola. And so let's write them here. Let's see. I've got the parabola that opens up and down. I have one that opens up and down, and then I have one that opens left and right. And they have different equations. So opening up and down, I'm going to have x minus h squared equals 4p times y minus k. In the opening left and right, this will be y minus k squared equals 4p times x minus h. So notice there are some similarities first to the circle, and second, similarities between the two of the parabola equations. The difference is which of these is squared. It's the easiest way for me to determine it. So when I'm opening, when I'm looking for which of these formulas to use, I'll look at this guy. I notice that it's the y that's squared. And so I'm going to work with this one. This one is going to open left or right. I happen to know that this one is going to open right. And I'll show you how I know that in just 1 second. So notice if you also look down there, the good news is that the vertex is kind of like the center of the circle. It is at h comma k. Okay. So that's going to be here and here. And that's what we're looking for first is the vertex. So hk, let's write those notes kind of down so you can clearly see it. hk is the vertex. And this p distance, if you remember back, and if you look at your formula sheet, p is the distance from the vertex to the focus and the directrix. So if you remember, I'm just going to sketch this off to the side. I'll go back up here and just kind of draw a little sketch. So if you have this parabola and it's going to open like this, you're going to have the directrix and you're going to have the focus. This distance is p, as is this one. If you remember, if this was 2, so was this. Directrix, focus, vertex, if you remember. That's going to give me that distance. So I need to write this equation in this format. Well, luckily it's pretty much done for me. This would just be 4 times 6, x minus negative 4. So let's take a look at what I did here and why I did it. Let's first notice that the vertex of this parabola is 6, negative 4. Actually, no, it isn't. It's actually negative 4, 6.
How did you know to put the multiply the 4 by 6?
Because the formula calls for 4 times some number to be here. And I can rewrite 24. That number is in the same location. And so I need to make this look like 4 times a number.
So you didn't really get it very well, you just like knew it, sure.
Well, I know that I have to make this number 4 times something. And I rewrote it as 4 times 6. Does that make sense? And then this is h, so that goes here. This is k, that goes here. So the vertex is negative 4, 6. But the first step is you've got to rewrite the given equation in the format that you're given so that you can find the information. Okay, This just asks you to find HK. H. Notice when it opens up and down, H is over here and K is over here. So you're going to be referring a lot to these. You will always have this with you. You can use this all the time, okay? All right. Which direction does the parabola defined by this equation open? And so here's how we figure that out. Step number 1, always rewrite in the general format. So this would be 4 times -9, y minus -7. Now, based on what you see here, is this one an up-down or a left-right? It's an up-down. Up-down, that's the first thing I noticed using the equation. And the way we figure out,
Can we just chart about where the x's and the y's are in the formula?
and then whether it's up or down is dependent on the sign of this number, the sign of P. If it's negative, it opens down. So this one opens down. All right. Really, when you're asked what direction it opens, that's really all you need. But I'm going to rewrite the whole thing in the correct format.
Will we ever have one that's like in that format, like x is first and y is second, but the p is positive?
Mhm.
Okay.
P is independent of those two things. P can be positive or negative because it can open up or down and left or right. So how can we rewrite -20 as a number times 4? 4 times -5. This would be x minus 1. Is this a left, right, or a up, down?
Left, right. No,
Okay.
up, down.
Ooh.
Left, right. That's what I was asking. Like you said, it's negative and it goes up and down.
No, that is not what determines it. What determines it is which one is squared. Here x is squared, here y is squared. So notice how this is an x, then a square, and this is a y, then a square. That's what determines the up, down, left, right. So if this is a left-right opening parabola, is it left or right based off this? What do you think?
Left.
Absolutely left, because left is left.
Oh,
Okay.
I thought you meant.
It's okay. All right, easy peasy on the opening. Easy peasy on the opening. Okay, so now find the axis of symmetry. So recall that in general, the axis of symmetry cuts the parabola in half or creates a line of symmetry for the parabola. So is this one an up, down, left, right? Which one? Up and down. So I like to sketch pictures to help me get a handle on things. I suggest you do the same. Is it going to be up or down? It's going to be down. So it's going to open like this. I know I'm going to have a vertex right here. I know I'm going to have a focus right here. And I know my directrix will be out here. So I just make this stupid little sketch. It helps me keep track of things, okay? I don't need a coordinate grid because there are just some relative features. Next thing I'm going to do is I'm going to rewrite this in the format of the general form of this equation. So that'll be 4 times -7, y minus -4. Well, in order to find the axis of symmetry, which is this green line, what feature do you think I need? What is it passing through? It's going to pass through that vertex. And can I get the vertex from this equation? Yeah, what is it?
Negative 4.
This one will be -8, -4. Remember, it is HK, and X goes with H and Y goes with K, so the H is over on the left this time. All right, so if this is the point 8,4, let's think about some things. This is the point -8, -4. What is the equation of this line? It's either going to be an X equals or a Y equals. Which one's it going to be?
It's x equals.
It'll be X equals. And is it going to be -8 or -4?
-8.
Why do you say it's going to be -8?
Because it's X.
Because it's the x.
Sure.
X equals -8. Now, if it was a horizontal line, we might choose the y coordinate. Because look, -4 is all, like, it doesn't matter. Like, if I'm trying to draw a vertical line, it's going to go through -8 because it's x equals. If I'm drawing a horizontal line and it's y equals, it'll be this one because that's the y. So the axis of symmetry for this one is x equals -8. Now, if you don't need this little silly diagram, if your brain can just think about, I just need the x coordinate of the vertex because the axis of symmetry is a vertical line, then man, you just knock yourself out. I'm not able to do that kind of acrobatic in my brain, so I draw the picture. Okay. All right. Now this one is a step past that one. This next one is find the focus. So remember, the focus is the point that floats inside of the parabola, and it is p units away from the vertex. P units. So the first thing we got to do here is let's rewrite this. So this is y minus 1 squared equals 2 times, or 4 times 2, x minus 6. Is this left, right, up, or down?
Right.
It's going to be a right opening parabola. So let's see. Open right if p equals is greater than. So let's just draw a little parabola here. Ooh. Here is the focus. Here is the vertex. Here is the directrix. So the first thing I'm going to label here is the vertex. The vertex of this one is going to be 6, 1, because this is h and this is k. So this point is at 6, 1. What is p in this equation? 2. So that means that this distance is 2 units. Am I moving horizontally or vertically? Horizontal. So which coordinate will change? X. It will change by how many units? 2. So the focus should be at 8, 1. Again, I draw pictures because eventually I'm like, I don't know which way I'm going. Am I going up, down, left, right, negative, positive, blah, 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 blah. And I find that picture just kind of keeps me straight. So find the focus of the parabola. Well, we just found it. We just found that one. How are we doing so far? It means okay. Are we good? All right. Next one. Okay, now it wants me to find the directrix. So the first thing I need to do is I need to rewrite this guy in the correct format, which this side's already good. This would be 4 times positive 10, so I immediately know it's going to be opening either, up or right. Which one's it going to be?
Right.
It's going to be a right opening with a vertex of what?
9, 7.
9, 7. Okay. So I'm just going to draw a right opening parabola. It's going to be ugly. I do not care. It doesn't matter. So this will be 9, 7. What is P? 10. So if I'm looking at the directrix, that's this guy. And it's going to be an x equals because it's a vertical line. So if it's 10 units away from 9, where is it located? -1. Give it a shot. So sometimes the directrix will be y equals. Sometimes it'll be x equals. It depends on which way it opens. But finding P is critical to locating the directrix and the focus. Okay. All right, now you'll graph some. So, huh? Oh. All right. So here's what you need to graph a conic section. This will be x minus -1. Notice it's always the same starting point. You want to get all of your key features revealed by writing it in this general format. Is this up, down, left, or right? Up. Y'all agree? Up. It's opening up. So this is up. What is P? 4. What is the vertex? It is -1, -5. All right. So I'm going to show you a little bit about another relationship. So the first thing you're going to do is you're going to do that vertex. 1, 2, 3, 4, 5. Then I always recommend finding the focus. The focus is going to be 4 units away. And if this thing opens up, the focus will be 1, 2, 3, and 4. But the other cool thing is, well, we know where it's kind of located here. And your directrix would be down here, another 4 units away. So this would be your directrix. You don't have to plot that, but I just want to show you. And then you would have this parabola opening up, but how wide is it? Well, from the focus, it goes either way, 8 units. How does 8 relate to this number? Yeah, so take that, go from the focus, it's going to go 8 this way, and it's going to go 8 this way. So it'll be a pretty wide parabola. Delta Math will do that for you pretty much. You'll see that when you go in. You'll just kind of have to move the focus around, and it should like widen the parabola for you. But you'll move the entire graph using the vertex, and then you'll stretch it using the focus and moving it to the appropriate place. So make sure you can graph that one. All right, that's graphing. Again, it's all about finding P in the vertex, right? Is that another one? I feel like you're still stuck, huh? You're still stuck. What is this? One more? I don't feel like we need to graph another one. Let's skip, well, I guess we'll graph it. Yeah.
What were the points that you went to the right and left? What were
Those points were this number cut in half.
Okay.
All right. All right, let's do this one real quick. Is this a left, right, up, down? It's left, right. Well, does it open left or right? Left, because it's negative. I've already found P, and the vertex will be -2, 7. Let me go find that. See, I'm skipping steps now. So if P is -1, I know P is, don't overthink P. You figure out which way this thing is opening, which is going to be left, and you just go 1 this way and 1 this way. Here's your directrix. This is your focus. And so then you would go 2 this way and 2 this way, because that's half of this number. And so it's going to open just like that. Make sure you can plot that in Delta. It's easier in Delta than on the paper.
Can you explain again how you knew where to put everything?
I plotted the vertex. P is the distance up from the vertex, one way to the directrix, one way to the focus. This distance is 2, and this distance is 2, which is 4. 2 and 2, which is 4. This is 1 and 1, which is the p-value. All right, hardest ones. Hardest ones, in my opinion. Good. All right, let's take the graph and write the equation. Take the graph and write the equation. So remember, when we are working with these equations, we need a vertex and a value of p. So the vertex here would be located at negative 5, 3. Remember, this is h, this is k. What is the value of p? 2 is the distance between the vertex and the focus. This is p. I mean, we pretty much got everything we need. We need to know which formula to use. It opens up versus down, so we'll use the one where the x is squared. So this is the formula I'm going to use. It'll be x minus h squared equals 4p times y minus k. And now I'm just going to start plugging things in. So this will actually be x plus 5 squared equals 4 times 2, and then y minus 3. Of course, 4 times 2 is 8.
Would you leave it as 4 times 2 or would you put it?
No, you need to finish it and make it 8 before you put it in, right? But all you need is p and the vertex. And you need to just figure out which one. I'm missing something. What is it? It opens down, so this has to be negative. Okay, so this would be 4 times negative 2. So remember, when we're counting distances, they're positive, but remember we have to also figure if it's opening down, that's going to be a negative. All right, that one was given the focus. Now let's do one given the directrix. Doesn't matter. P is still the vertex to the directrix, just like it was the vertex to the focus. This one opens left and right. So we're going to use a different formula. This one's going to be y minus k squared equals 4p times x minus h. Oh, remember I need a vertex. What is this? 3, negative 3? This is h. This is k. What is the value of p? 2 from the focus to the directrix. So that's 2. This opens left or right?
Left.
So p should be positive or negative?
Negative.
Absolutely. Well, now we just go plug it in. Y plus 3 squared plus negative 2 times 4 is negative 8. That should be equals. This will be negative 8 and then x minus 3. There's your equation. So we've got like 5 minutes left in here. And so the practice problems, they will not be due until Wednesday. Okay. But be aware that we are learning the rest of the conic sections tomorrow, and you will have an additional assignment on top of it. So don't wait till the last minute, but I'm not going to make it due tomorrow since we didn't have any class time to work. So what so far is due on Wednesday? Corrections and the rest of this delta. Okay. Not until Wednesday, not tomorrow. Yeehaw. All right. That's all I got for today.